Welcome to the QA Ops channel. In today's technical deep dive, we are tackling the critical middle ground of your testing strategy, integration testing. Where unit tests prove your logic works in memory, integration tests prove your code communicates correctly across boundaries. Architecturally, we divide it into three distinct phases: code integration, component integration, and system integration. Code integration validates internal module linkages, but the real pipeline challenge begins at component integration. This is the narrow integration tier, where a single microservice is tested against its immediate, out-of-process dependencies in isolation. At this component level, if your service owns a schema, test against real infrastructure. Using test containers, spin up real ephemeral Docker containers for Postgres or Redis. For event-driven architectures, you must spin up an ephemeral Kafka broker. Mocking Kafka hides serialization faults and partition routing errors that will absolutely crash production. Now, what about service-to-service communication via REST GraphQL or gRPC? Is it worth spinning up downstream microservices in this phase? The answer is no. Spinning up external dependencies during ephemeral PR builds leads to fragile, broad tests and cascading failures. Instead, virtualize external boundaries with WireMock or other tool and utilize consumer-driven contract testing. This mathematically guarantees API compatibility without the compute overhead. Once the ephemeral component tests pass, we advance to system integration. This happens post-merge or in a dedicated aggregated pipeline stage. Here, the compiled artifacts are deployed into a transient Kubernetes cluster to validate the true service-to-service mesh network, load balancing, and configuration injection. Suppose Service 1 calls Service 2, but Service 2 acts as an orchestrator calling a massive web of downstream dependencies. Do you accept this cascade and hit real infrastructure? Allowing transitive downstream calls is a severe anti-pattern that creates a fragile, unmanageable E2E test, and we wanted integration, not E2E. Instead, you must do deep virtualization. You deploy only Service 1 and Service 2 into the ephemeral environment to validate their specific network hop and payload serialization. For the downstream web, you deploy a mock orchestrator. You must dynamically override Service 2's environment variables, routing all of its outbound traffic directly into the mock. This achieves absolute boundary isolation. We must also apply this strategy to the frontend. Frontend integration testing should not require spinning up the entire backend monolith. Instead, isolate the UI component integrations by intercepting network requests. Use tools like Mock Service Worker or MSW to simulate backend API responses. This strictly validates your frontend state management and data fetching logic with zero backend dependency. Finally, orchestrating this in the release pipeline requires strict quality gates. Integration suites must run in parallel while we enforce three rules. 1. A strict 100% pass rate. Any instability indicates data leakage between tests. 2. Hard timeout thresholds to prevent locking up CI runner nodes if a container hangs. And 3. Contract verification must pass before the artifact is permitted to enter the deployment registry. To summarize, separate your component tests from your system tests. Spin up real databases locally, but stop downstream services until the cluster validation phase. Isolate front-end integrations at the network layer and enforce strict isolation in your CI pipelines. Thank you for watching. If you found this architectural breakdown valuable, please subscribe to the QA Ops channel and leave a like.